In this video, we're going to solve an end of chapter problem for chapter 9 on inventory management. The problem we are solving, it's trying to give us an idea of what happens to cost if we use an incorrectly calculated EOQ. By incorrectly, we mean the formula was used correctly, but one of the inputs was wrong. Because when you calculate any parameter for inventory management, you have some inputs like what is the demand and so forth. And if one of the inputs is wrong, your inventory parameters are not going to be optimal. So what's the cost of having a parameter that was wrong? That's the idea of the question. So in this question, what we do is we expect demand to be 85 bags per week. This is what we expect it to be, and the number may be different for you, but actual demand turns out to be different. In my situation, it only turns out to be 65 bags per week. When you see the problem, this 65 might be some other number. And so the mismatch between our forecast of demand, which we use to calculate the EOQ, and the actual demand, how costly is that? Okay, so what we're going to do is first we're going to assume that we had perfect information and we knew that our demand is going to be 65. So if demand is going to be 65, we calculate EOQ for using 65 bags. Everything is perfect. That's going to be the minimum cost situation. We find that cost, and then we find the cost on what actually happens. And what actually happens is demand is 65, but our EOQ is based on 85 bags. So when I say EOQ 65 bag, that means EOQ calculated using an assumption that demand is 65. And when I say EOQ 85 bag, that means EOQ calculated assuming demand was 85, right? So this would be that we calculate EOQ based on our forecast, and then we never revise it. So even when we see the demand is actually low, we just keep using the pre-calculated EOQ value in our system. And so how costly is that error of having EOQ for our forecasted demand when the real demand is actually different? Okay. So case 1, everything is going to be based on 65. Now if we go to our slides, we see that in chapter 9 inventory management part 1 slides, we talk about EOQ under the lot sizing economic order quantity section. On slide 20, we have the relevant total cost equation, which is Q over 2 times capital H, which is the holding cost, plus D over Q times capital F, which is the ordering cost. Ordering cost plus the holding cost is the total relevant cost for the EOQ. And then we have the EOQ formula, which is also sometimes called Q star, which is 2D, which is annual demand times S, the ordering cost per year, divided by capital H, the holding cost for 1 unit of inventory per year. Okay. So just to make it very easy, I'm just first going to calculate capital H because we're going to be using it a lot in our formula. So it's useful to calculate it separately. And capital H is going to be your holding cost as a percentage times the cost of an item. So small h times small c. Small h is 20% or 0.2. Small c is 10.5 for me. The numbers may be different for you. So for me, the numbers being shown here, we need to spend $2.1 to hold 1 bag of this product in inventory for 1 year. Okay. Now I can find my annual demand. That's also I'm going to use it repeatedly. That is going to be your demand per week, which is 65. The real demand per week times I'm open for 50 weeks in a year. So my annual demand is 3250. So this is based on the 65. Okay. Now we can calculate EOQ very easily. It's square root of 2 times annual demand times the ordering cost, which is given here to be 50. So I'll use 50 divided by capital H, and that gives me 393.397. Then I can calculate my holding cost and ordering cost, and the sum of the two is going to be my total cost. If you wanted to, you could calculate this whole formula on slide 20 in one go, just total cost, but I like to do it in parts. So I'm going to do the first part here, Q over 2 times H, that's the holding cost, then the second part separately, then add the 2. Doing things in parts allows me to verify my work and fix errors more easily. Okay, so holding cost is going to be Q over 2. Q is just the EOQ quantity times the holding cost H, and then the ordering cost is going to be your annual demand divided by your Q times the ordering cost S, which in this case is $50 per order. Okay, when everything matches, like your EOQ is the right EOQ, these two costs are going to be equal, and the total cost will be this plus this, so $826. Now we're going to look at what happens if our EOQ is not optimal. If instead of 393 we use a higher EOQ value because whoever calculated EOQ was expecting sales of 85 per week. Okay, so what is that incorrect EOQ value? That is going to be square root 2 times the annual demand. So actually let's do that here. Let's do it here. D85 annual demand when weekly demand is 85 is just 85 times 50, because we have 50 weeks in a year that our business runs, given in the question right here, right? And then EOQ, we can use the same formula, square root 2 times D times S, cost per order, which is 50, divided by capital H. Capital H is the same because it depends on the 20% and the 10.5, and these two numbers are not changing. And so EOQ is 449. Okay, it should have been 393 because demand is less, but we're using 449 because when we calculated EOQ, we're expecting a higher demand. So what happens if we use a higher EOQ than the optimal value to manage our inventory? So let's see our holding cost and ordering cost. Obviously, using a higher EOQ should result in a higher ordering cost. So we should get a higher ordering cost, Q over 2 times H, which is not changed, right? So we do see that instead of 413, the holding cost now is higher. Okay, let's look at the ordering cost. So the demand, we have to use the actual demand, because if we use this demand, that would be incorrect. This was our forecast. So this was our forecast, but actual demand turned out to be different. It turned out to be 65 per week. So when we calculate the actual cost that it costs us, we no longer want to use the forecast, we want to use the actual demand. So we can compare how much the error in how much our forecast error is going to cost us in the inventory cost. We can find that, the cost of the forecast error. And so the ordering cost, we're going to use the actual demand divided by the EOQ we are using, 449, times the holding cost S, which is 50. Okay. And you can see that by using a higher EOQ value, we actually save a little bit on the ordering cost. Instead of 413, we pay only 361, right? And then total cost is just this plus this, the sum of the two. That's 833. So our total cost is a little bit higher, even though our forecast error was huge. So look at the magnitude of the forecast versus actual demand. Okay, actual demand. So forecast was 85, actual demand was 65. In terms of MAPE, okay, that's an error, which is a 30% forecast error. So we make a 30% forecast error, and look how little our cost goes up. Okay. 33. Now, if my number is wrong, that might be because I'm not rounding the EOQ. So we might want to, oops, sorry, I have to put in the difference, not the actual value. So the difference, how much higher the costs are, is this minus this difference. So 7.44. Okay, so that was correct, right? And so it's costing me only $7.4 to have made that huge forecast error. So what that tells us is EOQ is pretty robust. Even if you have some idea of demand, you don't know demand exactly, and you calculate EOQ based on your idea, and actual demand turns out to be different, your total cost is not going to increase that much by even a relatively moderate sized or a large forecast error. So that's good. That is very good. So now part B is going to be similar. Suppose actual demand is 65 bags, but ordering costs are only 12. So instead of 50, the ordering costs are now 12 because we automate the ordering process. However, the buyer does not tell anyone, and the EOQ is not adjusted to reflect the reduction in S. How much higher will the total cost be compared to what they could be if the EOQ were adjusted? So we're going to do, let's make a copy of that, something very similar. Okay, so create a copy. This is part B now. And in part B, our ideal case is that our demand is 65 and we calculate EOQ using S of $12. Our new, case one, this is like the ideal case, using the lower ordering cost. Okay, and case two is that we do use the correct demand. We know demand is 65, but we continue to think that the ordering cost is still 50. Whatever it gave us, S of 50, whatever it gave us here. Okay, and then we can compare the two costs. Everything is going to be very similar, except we have to change S. So we might want to put S here. S is $12, right? So in the EOQ formula, whatever I put 50 previously, I'm going to replace that with S of $12. And so to see how reducing the ordering cost reduce my EOQ quantity. And then here where I have $50, I have to multiply by actually $12. And so my total cost is much less. So this is the ideal case. Okay, I use the correct demand, I use the correct ordering cost. And case two is we do use the correct demand. Okay, so we do use 65 because there's no forecast error in part B. It doesn't tell us anything about forecast error, right? It's just comparing on the ordering cost. But we do have a wrong ordering cost of 50 for some reason. Okay, and so when we do this calculation, we need to multiply by 50, not 12. So you need to use this 50, not the $12. And we'll get an EOQ which is much larger than 192 because we think our ordering cost is a lot higher. So inventory analyst thinks S is 50, whereas in reality it is only $12, right? So inventory analyst is continue to use S of 50, so we get this EOQ value, and now our holding cost is going to be based on this EOQ value, and our ordering cost is also going to be based on the the ordering cost, actual ordering cost is going to be with $12. Okay, and then the holding cost is the holding cost. It doesn't depend on S, right? And notice because we got a higher EOQ, we expect to get a higher ordering cost, right? And because there's a trade-off between the cost, higher ordering cost means lower, higher holding cost means lower ordering cost, right? So we will get a higher holding cost because the EOQ is a higher number than it was here, because we think the S is too high, okay? Right, and so when we compare the two scenarios, our actual ordering cost is much less than we expected, but our holding cost is more because we're using this inflated EOQ value. So we cost 512, and it should have cost in ideal situations 404. So the increase in cost is 107.5, about 107.48. Okay. And so that is the end of the question. So, part A and part B, all they say is that one of the inputs to EOQ, the actual value is different than the value the inventory analyst use. So your EOQ value is actually suboptimal. So this is the suboptimal EOQ value here. And in part A, this is the suboptimal EOQ value. So ideally you should be using EOQ of 393, but by a mistake you end up using 449. Or in this case, ideally you should be using EOQ of 192, right? But because of a mistake in ordering cost that you end up using a wrong EOQ. So it's showing you what happens when you make a mistake. And you can see that when you make a mistake on demand forecasting, you don't pay much, it's not a big deal, right? But when you, well, actually the difference here is very high as well. Like 50 and $12, that's like 300% error. You're off by like 300 something percent. You're 3 times higher than what you should be. If the error was only 30%, if this was like only, let's say, 15, you'll see that you're very close. The amount of money, there's almost no change, just $2, right? But because your error is so huge, you should be using $12, you're using $50, you end up making, but still, with a 3 times bigger error in S, you still end up only, costing a little bit more, like 25% more on the total cost. So that is it for this problem, and the goal of the problem is to show you how EOQ is very robust to errors in the input. So even if you don't know demand exactly, you don't know the ordering cost exactly, having some guesstimate of those values or estimate of those values to calculate EOQ is still better than not using EOQ, because once you calculate EOQ and you're in the ballpark, you're gonna be not too far off in terms of total cost.